Now let's look at the problem of overfitting. So decision tree, if you let it go, it will keep branching and branching and branching until the last leaves are completely pure. So when you do that, then you're overfitting, and such a tree will never generalize well to the validation data set. So how do you stop the growth? So the natural end process is 100% purity, right? And that overfits the data, and so you end up fitting the noise instead of the signal. So overfitting leads to, when you do that, then it leads to low predictive accuracy for new data, and past a certain point, the error rate for the validation data will start climbing. So, for example, um, as the number of splits increases, as the number of splits in the tree, so the tree size increases. Okay. Now, training data, of course, is going to become the rectangles will become purer and purer. So the performance measures for the training data will continue to decline. It will keep going down and down and down. But then after a certain point, the misclassifications and the performance measures will bottom out, and will start going up for the unseen data. So the trick is how far down you want to go in the tree, and stop when the tree starts to fit the noise instead of the signal. So there is no single formula or something that we can use and say, okay, here is where I need to stop. So you need to do some trial and error. And fortunately, SAS Enterprise Manager automatically does this. You just set some tuning parameters, and SAS will do the rest for you. So, so one way of doing that is to say, okay, I don't want the nodes to have less than a certain number of observations. So as you branch, once you reach a rectangle that has less than, say, I don't know, 20 observations, then you don't want to branch anymore, right? So that's one way. And another is, say, okay, I don't want a tree that goes beyond a depth of 5. So starting from the root node, so no branch should have more than 5 or 6 or 7 nodes in the branch, right? So you can limit the tree depth. Again, you can set that in SAS. And then we have statistical significance, okay, the p-value, the log worth that we talked about. So you can set a limit for that. You can say if it goes below a certain, so remember, log worth, larger the better, right? So you can say, all right, so given a certain level, okay, you don't want to go beyond a certain log worth, which will achieve purity of noise rather than purity that will replicate for the validation data set. So this is top down, when you're limiting how far the tree will grow. Okay, so that's top down approach. Pre-pruning. Post-pruning is when you build the tree to its complete purity, right? You build the maximal tree, and then you back up. You back up based on accuracy or least squares in the case of interval variable. So you back up and see where you get the purity or the benefit of a smaller tree, okay, with the loss of purity. Okay, if the loss of purity is minimal, okay, then you do want that pruning to happen, right? So and that's so splitting stops when the purity improvement is not significant, statistically significant. So that's your, so there is shade and then there is cart. There are two possible approaches. Okay, they use statistical significance test to limit the tree growth, and so here are some parameters that you can use for top-down pruning in SAS. So you can say a significance limit for log worth, okay, maximum depth, okay, leaf size, so how many observations must a leaf have, and you don't want to go below that. So to specify pre-pruning, only set subtree method to largest. So if you set the subtree method in SAS to the largest, then you do only pre-pruning. And then you can set p-value adjustments, the number of inputs, and depth adjustments, and so on. So here now I've discussed this in SAS video, so you can take a look at the SAS video. Okay. Now post pruning, so the method cart lets the tree grow to the full extent and then prunes back. The idea is you use the validation data set for pre-pruning, and you keep pruning, post-pruning, sorry, and you keep pruning, and every time you prune, you check with the validation data, and then you stop once the loss of once the validation set gives you significant, as you prune, the smaller tree loses misclassification rate increases significantly. Then you stop and come back and increase the tree. So generate successively smaller tree by pruning leaves. On each stage, multiple trees are possible, and you can also use cost of complexity method to stop, to find the best tree, and that works like this. So you have the error of the tree, the misclassification, proportion of misclassified records in the trained data, and then you have an alpha factor. Okay, it's a penalty, and you set the penalty, so, and then you have a function L T, and that is the size. Okay, so that's our cost complexity tree. So start with, so LT is the size of the tree. So as the size increases, then if you set alpha equal to 0, then the size doesn't matter. The only thing that matters is the classification error. And if you set alpha like 100, then every time you increase the size, then you're adding 100 to the error, or whatever the alpha value. Alpha value can be more than 1. So if you have a value of 2, then it's going to keep adding that level of penalty to your error. So start with maximal tree with alpha of 0, and you gradually increase alpha until CCT of the subtree with one less node is smaller than the CCT of the current tree. Okay. So that gives you alpha value, and then you repeat until the tree of every size is generated, and the tree with lowest misclassification error is chosen. And as you prune the trees and find the best, there are two decision trees that are of interest. One is the minimum error tree, and that's the one that has the lowest error rate on the validation data set. And then the best prune tree would be when you prune and you get not the least error rate, maybe slightly higher error rate, okay, but smallest tree within one standard error of the minimum lowest error. So you're allowing the error to be a little bit larger than the lowest possible value, and what is the small within the one standard deviation limit, what is the smallest tree possible. So the idea being that if you're only one standard deviation from the best error possible, it's still good enough if you get a really small tree. So that really small tree has a value of itself, and you're willing to settle for error rate that is within a standard deviation from the lowest possible value. And in SAS, you can set the subtree method to assessment, which means you'll use pruning, and if you set to largest, then it will give you the maximal tree, or you can set to n, which means that you want a tree of a particular size. And you can set the if you select assessment for your method, then you can select one of these 4 possible options for the assessment measure. Decision is when you set cost, profit and cost values when you set the metadata for the data, or average squared error, or misclassification rate, or lift, or the three other possibilities. In post-prune in SAS, okay, you use subtree method. Of these three assessment measures, we already looked at that.